Welcome to this explainer. Okay, I am so thrilled you're here today because we are diving headfirst into a massive detective story. This isn't just about cracking open a dusty textbook. We're talking about the ultimate investigation into human curiosity and the actual rules of reality. Since day one, humans have looked around and just been fascinated by how things work. So we're going to unpack exactly how we started figuring out the universe using the greatest tool we have.
I mean, have you ever actually stopped to wonder about this? You drop a pin, it falls. But why down? Why doesn't it just float away? It's kind of wild that we take this everyday mystery completely for granted.
Or think back to being a kid in the backseat of a car at night. Remember how the moon just seemed to follow you no matter how fast you were driving? It's this beautiful illusion that is deeply rooted in celestial mechanics.
And what about the invisible mechanics happening around you right at this very second? How does light travel at such breakneck speed to hit your eyes? Or, how do the sound waves of my voice, vibrating out of your speakers right now, reach your ears so you can actually understand me?
Okay, let's dive into this. When you take all those specific, everyday questions and zoom way, way out, you're left with this one ultimate puzzle. How does this entire universe actually work? And trying to answer that massive question has a very specific name.
Section 1. The Power of Curiosity, Seeking Answers to Nature's Rules.
You see, this whole journey wasn't just invented on a random Tuesday. The very moment early humans started watching the sun rise, the rain fall, or fire heat things up, they started asking why. And that basic, relentless curiosity leads directly to our core definition here. Physics is the science that attempts to understand the fundamental laws of nature. It's really not about memorizing complex formulas. It is literally about decoding reality itself.
Let's look at how this plays out in real life. When you toss a ball up and it comes back down, that's gravity. When you're driving and slam on the brakes, causing the car to jerk to a stop, that is force in motion. Right now, the phone in your pocket is holding a charge because of electricity and electromagnetism. Honestly, even just looking up at the stars tonight, that's physics in action. It is happening constantly, right in your hands and all around you.
Section 2. The Scientific Method, from Ancient Observation to Modern Science. So, to go from passively watching nature to actively decoding it, humanity had to build a system. And this simple sequence is the absolute backbone of all modern science. First, you observe something happening. Second, you question it. You literally ask, why is this doing that? Third, and this is the absolute crucial part, you experiment. Fourth, that experiment gives you a result. And finally, you draw a conclusion based on that hard data. This exact, brilliant loop is what unlocks the truth of the universe.
Section 3. The Giants of Physics, the thinkers who changed the world.
The crazy thing is, we didn't always use that perfect scientific method. Take the ancient thinker Aristotle. Brilliant guy, sure. He had these amazing ideas about motion and matter, but he relied mostly on pure logic without really testing things out. But then along comes Galileo. He basically launched the modern era because he realized ideas just weren't enough. By relying heavily on physical experiments, especially observing motion and gravity, he proved once and for all that our ideas absolutely must be rigorously tested with real evidence.
Let's trace this journey chronologically so we can really see the evolution here. We start way back in the ancient era, with early humans just observing basic elements like fire and the sky. Then we move into Aristotle's era, leaning heavily on logic and philosophy to explain nature. Next, we leap forward into Galileo's era, where we finally introduce physical experiments to test motion. And that totally paves the way for Newton's era, where the laws of motion and universal gravitation actually get mathematically formulated. It really shows how physics is this constantly evolving, deeply human endeavor.
And actually, speaking of Isaac Newton, we have to pause here for a second. Newton realized that the exact same force causing a simple ball to fall to the ground here on Earth is the very same force keeping massive planets orbiting in the sky. He literally connected the dirt beneath our feet to the infinite cosmos above using just one unifying concept, universal gravitation. I mean, what a game changer.
Section 4. Entering the quantum world, beyond classical gravity. Now, as our knowledge expanded, physics started splintering into these fascinating new branches. Just look at how vast this field is today. You've got mechanics and thermodynamics handling motion and heat, electromagnetism and optics tackling electricity, magnetism, and light. Then there's relativity, studying the mind-bending connections between space, time, gravity, and motion, right alongside astrophysics, which explores the stars and galaxies. And of course, quantum physics, zooming way, way in to study extremely small subatomic particles.
But here is where things get truly wild. When scientists started looking into atoms, and particles even smaller than atoms, they discovered something completely shocking. At the microscopic level, the normal, classical rules of the world just break. I'm serious. Particles like electrons and photons behave in these totally mysterious ways that completely defy our everyday logical experience. The quantum world is this bizarre place where Newton's classical physics just aren't enough to explain what's actually happening.
Section 5. Physics in our lives. The science powering the modern world.
So, you might be wondering, why does all this matter to you right now? Well, because the screen you're watching this very explainer on exists solely because of physics. Smartphones, the entire internet, GPS satellites orbiting our planet, the electricity powering your home, life-saving MRI and X-ray scanners, even nuclear energy and spacecraft exploring the void. None of this modern technology exists without these fundamental principles. It is quite literally the foundation of our modern life.
Section 6. The unanswered questions. The mysteries that remain.
But here's the thing. Despite centuries of brilliant minds and all this incredible technology, there is still so much we just don't know. Like, what exactly are dark matter and dark energy? They make up the vast, vast majority of our universe, yet we can't see them and barely even understand what they are. Scientists right now are still desperately hunting for these answers.
Physics is this continuously open book with completely blank pages just waiting to be filled. I mean, what actually happens inside a black hole where gravity is so intense that not even light can escape? Or perhaps the biggest, most mind-bending question of all, how did the universe actually begin?
And then there's the ultimate unsolved puzzle of modern science. How do we take the incredibly strange, microscopic rules of quantum physics and combine them with the massive cosmic rules of gravity to create one single unifying theory? This is the absolute frontier. This is the exact puzzle that physicists today are dedicating their entire lives to figuring out. So, I want to leave you with this thought to carry with you today. Physics is not just reading formulas. It is learning to see the science hiding all around you. I really hope this explainer inspires you to look at your daily environment, whether it's a falling leaf, your glowing phone screen, or the night sky, with a newly curious scientific eye. The universe is speaking to us. We just have to learn its language. And you know what? This is really just the beginning of our journey. Now that we understand what physics actually is and where it comes from, we need to dive into the core mechanics of how things physically work. So in our next explainer, we are tackling motion. How do objects move? We're going to explore speed, velocity, acceleration, and finally unpack Newton's laws in total detail. So the next time you drop an object or hit the brakes in your car, ask yourself, what invisible forces are really controlling your every move? See you next time.